So let me give you an example of how to sketch graphs. So here, sketch this function here. Before calculus, we did a whole section on how to sketch complicated graphs. And the way we did it was that we looked at this block here. When x is big, it wants to do this. When x is small, it wants to do this straight line here. So the way we did it before calculus was to do this here. When x is small, it wants to do this. So it will have an intercept of -3. So -3 to be around here, and then it will want to have a gradient of +2. So it wants to do this gradient of 2 here. And when it's big, it will want to do a negative cubic. So it wants to do this, a negative cubic. So, but that's only valid when it's big. So so around this region here, it wants to do the negative cubic here like this. But it's only valid when it's big around this region here. Okay, so here, so the way we did it last time was that when x is small, it wants to do this straight line, so it wants to do this. When x is big, it wants to do this negative cubic. So we would guess it to be something like this. Hang on, to be something like this, and then something like this. Okay, so this was what we used, how we did it. This was how we did it last time before calculus. So now that we know calculus, we can now find out the turning points here and the turning points here. And the way before calculus, we couldn't do this. We would just guess. So our guess, it could actually do this. The graph could actually do this, or it could go over the x-axis. We don't really know, so we would just guess. So now we can use calculus to actually find out if it really goes over the x-axis, or, well, for the time being, let's just assume it goes over the x-axis. So now we need to find out the value of x here, where the gradient will be 0, and we need to find out this value here where the gradient will be 0. So we will need to differentiate this whole thing here. So the next aim here is to differentiate this whole thing and then find out when the derivative will be 0. So here, so looking at this whole thing here, differentiate it, it will give you this. It will give you this. Okay. So find out when this thing here will be 0. So set f of x to be 0. So we now want to know when the derivative will be 0. So set this thing here to 0. Okay, so now solve this. So now it's just a matter of using now it's just a matter of somehow solving this quadratic formula. So there are lots of ways of doing it. You can use a quadratic formula. Well, we've done a whole section on how to solve this. So here the way we did it was from here divide everything by -18. So this divided by -18, it will give you 0. This divided by -18, it will give you this. This divided by -18, it will give you this. This will give you this. And then the way we did it was we zoomed into these two terms here. How would you create these two terms? Well, you're always going to need half of this. Okay, and then sorry, hang on. Sorry, the way we did it. Sorry, hang on. Let's start again. So we were here. The way we did it is to divide everything by 18. So that would then take us to this. Simplify this. It would then give you this. Okay, simplify this. It would then give you this. And then the next step was that we zoomed into these two terms here. We're always going to need half of this. So half of this would be this, and then we've got to take away the rubbish. Now, if you don't understand what I'm talking about, then you've got to watch a section on solving quadratic equations. So we need to take away. We need to immediately take away the rubbish here, and then carry this down here, and then it's just blah 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 blah, and then blah blah blah, and then x equals this or this. Okay, so what that means is that our graph looking like this, our sketch, it was -3 with a gradient of +2. Okay, and then it wants to do a negative cubic. So we guessed it to be something like this. Okay, and then what we now know is that looking at this here, the gradient here will be 0 here. So this point here is 0.62, and then here you've got another point where the gradient will be 0. You see, at this point here, it will be 0. So the gradient will be 0, meaning that the turning point is right here. So this bit here is minus 0.18. Okay, so we know the turning points will be here, not to scale, by the way, because minus 0.18 should be somewhere around here, but leave it for the time being. Now, so we know that the turning point will be here, and we know that the other turning point will be here. The thing is, you see this bit here, it could go under the x-axis, or it could go over, and the way we find out is by putting this into the original function. So when we put it into the original function, so this here was our original function. Put this 0.62 into the original function. That will then give you this. Okay, and then put the other value here into the original function. That will then give you this. Okay, so looking at this here, you see when we put this when we put this thing here into the original function, it gave us a negative y value here. So what that means is that it gave us a negative value. So what that means here is that our guess was that it went over like this. But when we put 0. whatever in here, it gave us a minus value. So it could the turning point must be in the negative realm here, because it gave us a minus value here. It gave us this value here. Well, it couldn't go over, because if it were to go over, then the y value would be positive. But it gave us a negative y value, so it must be in the negative realm. So it gave us this. Well, so yeah, so by you putting this into the original function, it then gave us the precise location. By you putting this into here, it gave us the y value of this, and then if you do the same, it will give you this value here. So hang on. So your graph will end up looking like this. Okay, and if you were to draw the derivative on top of the graph, it would look like this. And looking at this here, the blue line's a derivative. The red line was our original function. When the blue line, when the derivative is 0, you can see that here there's a turning point here. Okay, and then here there's a turning point here. Okay.